This is a video for Year 7 Theta, Knowledge Organizer 3 on solving equations. So I'm going to demonstrate the balancing method and also the bar method to solving equations. So I've written a couple of examples. So this is from exercise 1, question 1a. And we've got x plus 4 equals 9. So I'm going to use the bar method just to demonstrate through a diagram first. So you can see here, I've drawn out a bar. This first bar is going to represent x, what we don't know yet, we need to work out. And this is going to represent plus 4. And we know x plus 4, whatever x happens to be, when I add 4 to it, it's going to equal 9. So this bar at the bottom is to show that the two put together equal 9. Now, x is part of this bar 9. And if we know that this part here is 4, then we can subtract the 4 from the 9 to leave us with what x is. So that means x has got to equal 5, because 9 subtract 4 equals 5. Now, if you notice, we are doing the inverse or the reverse operation to adding 4. So in order to solve equations, we actually do the inverse of that. We subtract 4. So the balancing method is what I'm going to demonstrate here. So the balancing method is this. You've got to think about the equal sign like a balance, like a set of scales or a seesaw. And this side here, the left-hand side, is balanced with the right hand side of our seesaw. So it's like a scale that can tip up and down. Now, solving means to work out the value of that letter. We want to work out x. So in order to do that, we want x on its own. We want x on its own on the left hand side or the right hand side in order to work out what it actually is. So in order to do that, we need to get rid of the other parts, the other terms in the equation. So I want to get rid of this plus 4. Now, if we think about inverse operations, to make positive 4 become 0, I want to take away 4. Okay. Now, if I take away 4 from this 4, it becomes 0, and it's gone. However, now, this side of the equation, the left-hand side, is now lighter. I got rid of this 4, and whatever we do to this side, we have to do to the right-hand side as well. So I've got to take away 4 on the right-hand side. So that means my next line in my equation for my algebra will be x equals 9 subtract 4, so x must equal 5. Now, this is a very simple example. It's just to demonstrate the balancing method, how what we do to one side of the equation we can do to the other side of the equation. Now, I'm fully aware you could do this sum in your head and you know 5 add 4 is 9, but by developing these skills at a lower level means when the equation gets more complicated, we are still applying the same skills. So those skills haven't changed, it's just the complexity of the equation that changes. But if you can apply the algebra method to a more simpler equation, it makes it a lot easier when you're trying to do a more complicated equation. So the same works if it's a subtraction. So you can see here, x subtract 37 equals 50. And the bar method works the same way. So if this entire bar here represents x, if I subtract 37 from that bar, I will end up with 50 left over. Now, if this 37 has been subtracted from the entire bar to give you 50, then x must be 50 plus that extra bit added back on. So x must be 87. And again, you can see that we're using inverse operations. So here it was negative. We're now doing an add to solve our equation. Okay. Now, if I want to do it using the balancing method, I can do the same thing. I want rid of this term here. So I want to get rid of negative 35 and bring that to 0. And in order to do that, I add 35. So that means I'll have just x on this left-hand side, because 35 take away 35 equals 0. But don't forget, it's the balancing method, so I've got to do the same on the other side. So I'll do 50 add 35 to give me the answer 55. Okay. Now, as the equations get more complicated, I will still apply the same method. I am still going to do the inverse operation. So it doesn't matter that it's now a multiplication. The inverse of that will just be division. So here, 2x. Remember, 2x means 2 times x, or 2 multiplied by x. So that means our inverse operation for times will become a divide. Okay. Now, I've done it here with the bar method. 2x, so there's 1x, there's my second x. All of that has to equal 24. So that entire thing is 24. I want to know what one of them are. So I want half of that bar. So x is 24 divided by 2. So that means x must be 12. Again, it is the inverse of what's happening here. So this meant times, and if you notice, I am doing a divide by 2. Now, if you want to do the balancing method, same thing. We want to get rid of this 2. We want to make it not 0 this time, but actually 1. We don't want 2 x's, we want 1x. So the opposite of timesing by 2, or the inverse of timesing by 2, is to divide by 2. 2 divided by 2 is 1. So 1x. Remember, you don't need to write a 1 in the front. It's the same as x on its own. But because it's the balancing method, I want to divide both sides by 2. So 24 divided by 2 is 12. Now, this balancing method that I'm writing down here, it is the preferred algebra method used to solve equations. It shows all the steps that you need to solve equations. It shows each little line and method that you're applying and every inverse operation that you're applying. So for the very last one, I'm actually just going to use the balancing method. Even though I've drawn a bar method here, I'm just going to do the balancing method. So 4x plus 8 equals 40. Now this is a much more complex equation. This is a two-step equation. The first thing that's happening to x is it's being times by 4. Then it is being added 8 to equal 40. Now, that means we've got to do all of those steps in reverse. So if you think about what I said, the first thing that's being done to x is it's being multiplied by 4. Then we are adding 8, and that is giving us the answer 40. Okay, we've got to do everything in reverse. So that means we have to actually get rid of the plus 8 first before we deal with the 4 in front of the x. So if we do the balancing method, the inverse of adding 8, subtract 8 from both sides. So 8 take away 8, 0. We're just left with 4x. I'm just going to write that down. Then I'm going to write my equals. 40 subtract 8, 32. Now you can see how I've lined everything up. My equal signs have always lined up in each example. And the same thing's going to happen here. Now this example, this line, matches similarly to the 2x example we had before. But this time instead of 2x, it's now 4x. So we're timesing by 4. So that means in order to get rid of it, I want to do the inverse of it. So I want to divide by 4. But remember, we're doing it to both sides. Divide by 4. 4 divided by 4 is 1. Leaves me with just 1x. 32 divided by 4 equals 8. Now, in all of these solving equations, I have reversed the operation in order to solve the equation. And there is also a nice little check that you can do for each question to make sure you've actually done it right. And you can check it by substituting the number back into the equation. So you can see in the original question here, it's 4x plus 8 equals 40. So 4x plus 8 equals 40. I've worked out here that x should be 8. So I'm going to put that back in. Remember, 4x means 4 times whatever x is. And I worked out x to be 8. So I'm going to write that down. And then I'm going to add 8 to that. Now, 4 times 8, 32. 32 plus 8 equals 40. This matches what I want here. So that's my work checked. And I know it's correct. Okay. Thank you.